Hi everyone, this is Dr. Sandeep, Associate Professor in the Mechanical Department, working in Institute of Aeronautical Engineering, Hyderabad. So in the previous session, we have discussed about the introduction to material engineering. So today's topic is about the physical and mechanical properties related to the material engineering. So what is the difference between the physical and mechanical properties? So this is very important. One need to know what is the difference between the physical as well as the mechanical properties. So what are the physical properties? So in general, physically, any body can be calculated or can be identified or can be measured with the dimensions like length, density, all those things. So those are the physical measurement values. Coming to the mechanical properties. So how these mechanical properties are differentiated with the physical properties means the mechanical properties are applied when a force is applied on the body. So how it is changing mechanically, elongating, or what is the strength, what is the ductility, what is the wear resistance. So these are all comes under your mechanical properties. So before knowing the material science, one need to know the basic difference between the physical properties as well as the mechanical properties. So what are the physical properties? Physical properties which are measurable. Physical properties are the things that are measurable, like the density, the melting point, thermal conductivity, coefficient of expansion. All this comes under the physical properties which are measurable. Now coming to the mechanical properties. So mechanical properties are nothing but how the metal is being performed when different forces are applied on the body. So different forces means whether it is a tensile, compressive, shear force. So when different shear forces are applied on the metal or on the body, how the metal is behaving, how the metal is being behaved. So like the ductility, the strength of the body, the hardness, and when the forces are applied, it undergoes to wear and tear. So all this comes under the mechanical properties. So the mechanical and physical properties of materials are determined by the composition and internal structure. Again, how can you define the mechanical properties means depending upon the crystal structure, atomic structure of the body. As we discussed in the previous class, different metals will have its own atomic structure, its own grain structure, everything. So in the same way, depending upon the atomic structure or the internal structure of the material or the composition of the material, so these can be used to calculate the mechanical properties. So different materials will have different grain structure, different crystal structures. So depending upon these crystal structures, you can easily identify the mechanical properties. So how can you identify the mechanical properties means based upon the grain composition. So in some metals, what is happening? We have, so this is the metal we have. In this, we have different grains. Like this, we have different grains. So now these grains are closely packed to each other. Like this, if they are closely packed to each other, then the bonding between the atoms is very strong. That means the strength of the material is very high here. Now when you compare the same material, another material which is having the atoms like this, that means there is some space, there is no good bonding. Now this is very weak. Okay, when you compare with these two bodies, so we can tell that this body is having a good strength and this is not having good strength. So how can you tell means depending upon the crystal structure. So every metal has its own crystal structure or atomic structure and the composition. So depending upon these compositions or the atomic structure or the bonding between the elements in the metal, we can tell the mechanical properties. Next, mechanical properties may be greatly affected by processing due to the rearrangement of the internal structure. Now, what are the material we'll get for the raw material? So that won't have a uniform structure. There are some disturbance internally. So how can you rectify that internal structure? Means by using some heat processing or cold processing. So you can use that processing technique. By the help of that technique, you can rearrange the internal structure. So how can you rearrange? Means again, take this example. So in this example, you have the grains like this. So these are all grains. They are irregularly placed. So this is our raw material. So we have this raw material. Now this raw material, we can do processing. We can do processing, whether hot or cold processing. We can do whether hot or cold processing depending upon our application. We can do this processing, and what we can do during this processing, we can rearrange the molecules or rearrange the internal structure, and we can get a good uniform bonding like this. So all over the material we can get like this uniform. So what is happening? The raw material is now converted into a good material. Why? Because there is a rearrangement here, rearrangement of the molecules because of the processing. So we can do the processing techniques, and we can rearrange the molecules and improve the material properties or enhance the material properties. So that is one of the processing techniques where we can improve the mechanical properties. Now other thing what we have metalworking process or heat treatment process. This plays this metalworking or hot treatment process plays a key role in the enhancement of the properties like density, electrical conductivity, and etc. So this is very important technique where we can enhance or improve the mechanical properties like metalworking. So as we discussed, like cold working process or hot working process, and even the heat treatment process, we can heat the metal. So once you heat the metal, what is happening internally, the whatever the not uniformly distributed material is there, they will uniformly distribute as shown in this example. So these are not uniformly distributed. Now once the metal is heated, so after heating, what is happening? These molecules are being rearranged into uniformly like this, so that you will get a good enhancement in the properties. And coming to the next point, mechanical and physical properties are the key determinant for which we can consider for the suitable application. So depending upon the properties of the material, then only we can decide this material is suitable for so and so application. Okay, so if you want to manufacture an automobile key, okay, for that key you need to select some material. You can't directly use plastic material. So why? Because you have to insert the key and you have to ignite the engine. So for this you need to have some aluminum alloy. So aluminum alloy, how you're selecting? You're selecting because you know the properties of the aluminum. Like that, for every given application, you need to use the appropriate material. So how can you use that appropriate material? When you know the properties of the material, then only you can use the exact material to the required application. So as we discussed, this is not restricted to only the mechanical engineering stream. It is related to every engineering stream. Even in the biomedical sciences also, the materials are being used widely. Now, what are the mechanical properties? We need to know different mechanical properties to describe any material. To describe any material, one need to know what are the different types of mechanical properties are there. So, if you see the common physical and mechanical properties for any material. So, first one is what? The conductivity we have, the thermal conductivity, how the heat is being transferred. That is first mechanical property. Next is the corrosion resistance. Next comes the density. The fourth one is the ductility or malleability. The fifth one is elasticity or stiffness. The sixth one is fracture toughness. Seventh one is the hardness, plasticity. Next comes the strength or fatigue. Next the shear strength, tensile strength, yield strength, toughness, and wear resistance. So these are some of the common properties which are available in each and every material or every element. Now one by one we will discuss what is the each property and how it is being transferred or how it is being varied and what is the importance of each property. We'll see one by one. So first one is the thermal conductivity. So thermal conductivity is nothing but, so in the name you have thermal, that means it is a heat. Okay, so thermal conductivity is nothing but it is a measure of the quantity of how much amount of heat is being transferred into the material. Okay, how much amount of heat is transferred into the material or how much amount of heat is flowing through the material is called the thermal conductivity. So how can you measure this thermal conductivity? You can measure the thermal conductivity, how much amount of heat is being transferred per unit time, per unit cross-sectional area or per unit length. So this is how you can calculate the amount of thermal conductivity which is being transferred into the materials. And the materials with low thermal conductivity can be used as an insulators. Okay, what are the materials which are having less thermal conductivity? These can be used as the insulators, and those which are having high thermal conductivity can be used as a heat sink. Okay, now how can you define the whether it is low or high thermal conductivity? Means you have to calculate how much amount of heat is being transferred per unit area, per unit length and per unit time. Now if you see this figure, you can easily understand. We have here two different bodies. So this is body A and this is body B. Now how the heat is being transferred means here A is having T2 which is high temperature, T1 is having very less temperature. Now at any point the heat is transferred from higher temperature to lower temperature. Okay, so this is having higher temperature, so slowly the heat is being transferred like this. Slowly heat is being transferred to the body B where the temperature is very less. Now slowly heat is being transferred, and how much amount of heat is being transferred from point A to point B you need to calculate. Okay, so materials which are having thermal conductivity are represented by K. So you need to find out what is the K value per unit area and per unit length. Then you can easily tell that yes, this metal is having a good thermal conductivity, so this can be used in heat sinks. And another body which is having very less thermal conductivity, so this body's can be used as an insulators. So this is how the thermal conductivity. So in different metals will expose to different temperatures. The automobiles what we have, so these continuously run, they generate heat. So once they generate heat, what is happening? The materials will get wear and tear. So it has to withstand. So you have to select a good material which is having higher thermal conductivity. Though continuously process of running of the engine, heat is being generated, it has to withstand, the metal has to withstand. How it has to withstand means, once you know the thermal conductivity of that material, then you can easily select a good thermal conductivity value or higher thermal conductivity material in the automobiles. And not only in the automobiles, in the aerospace applications, in industries, in the manufacturing industries, and a number of applications where heat is generated, high amount of heat is generated, there the material has to withstand. Okay, in that applications, you need to select a material which is having a good thermal conductivity value. Now, the metals that exhibit higher thermal conductivity, these can be used in the applications like heat exchangers and refrigerators also. So as we discussed now, after calculating the thermal conductivity value, so whatever the material which is having higher thermal conductivity rate, these materials can be used in heat exchangers as well as refrigerators. Why means there is a huge change of heat, exchange of heat, generation of heat. So because of those, the material has to withstand, the heat exchangers has to withstand. That's why the manufacturing of the heat exchangers or the refrigerators are done with the materials which are having a higher thermal conductivity values. Similarly, lower thermal conductivity values, as we discussed, these can be used as a insulators. Now, if you see this figure, this is another example of electrical conductivity. So, in the previous case, we have seen about heat conduction. In this case, electrical conductivity. So, both are same. Okay, energy is being conducted into the material in the form of heat in the previous example. Now, in this example, current, how the electricity is being conducted into the materials, that can be defined as a electrical conductance. In the previous, we have seen thermal conductance, heat conductance. Now this is the thermal conductance, electrical conductance. So this is nothing but the quantity of how much amount of electricity is being transferred into the material is known as the electrical conductivity, and this also can be measured, how much amount of uh, electricity is being transferred across the cross-sectional area and across the length of the wire. So this is how you can find out the conductance, whether it is electrical or heat, through the material. So this is very, very important. So in this example, if these copper wires, what are the copper wires? If these are not good conductors of electricity, what happens? What happens once the current is being passed between these wires? It will break if it is not a good conductor of electricity. So you need to select a material such that you should have a good thermal conductivity. So that's why we mostly coppers are being selected as the thermal conductivity, electrical conductivity in wires. Next property is about the corrosion resistance. This is also very, very important. So corrosion resistance is nothing but the material's ability to prevent from the natural or chemical chemical attacks, or environmentally whatever the gases are being exposed, or by atmospheric conditions or moisture or some other agents. So when these are all reacting with the material, what is happening? Suppose if water is being flowed continuously on the metals, so after some time, what is happening? Slowly corrosion will come into picture. Okay, it will form some scales on the material. Even some chemicals which are being exposed, or some chemicals are being touched to the heat exchangers. What is happening? Slowly some scale is being formed. After some scale, so slowly corrosion will form. So what is the use of that corrosion? Means there is no use. Because of that corrosion, the material will get failed after some period of time. So this you need to avoid. Okay, so though the material is exposed continuously to some atmospheric conditions or natural calamities or chemical reactions, your material has to withstand. Suppose in heat exchangers or in boilers, what we do? We'll boil the chemicals to high temperatures. Okay, now these chemicals, they react with the material of the heat exchanger or the boilers. So what happens when these chemicals get contacted to the material? So what is happening? There is some reaction is happening between the material and the liquid. So because of that reaction, so there is a formation of corrosion. So because of the corrosion, what is happening? Material is getting failed after some time. So this you need to protect. Though we are using some external applications, okay, so but still our material get failed because of the corrosion. So all these things you have to take into consideration, and you have to select a good material which is having a less corrosion. In the previous, you had to select a material which is having higher thermal conductivity, and in this case you need to select a material which is having less corrosion resistance. Why? Because different applications will generate different types of oils or chemicals or some reactive agents. So all these things will react to the material. Okay, because of that reaction, the scale is being formed. So because of the scaling, corrosion, so material get failed. So all these things you need to take into consideration, and you have to select a material which is having less corrosive resistance. Now you can see this example, you can easily identify what is corrosion. So this is the newly manufactured bolt. Okay, so what is happening if this is exposed? If this is exposed to some chemical reagents or some water or some environmental gases, so what is happening? Slowly it is being corrosion. So this is how you get the corrosion. After some period of time, after 1 year or 2 years, so what is happening? Whatever the thing you are seeing in the initial stages, you can't see here. So completely the material is being exposed to some gases or some chemicals and it is being formed like this. So this corrosion, because of this corrosion, there is a failure in the selection of material. So in order to avoid this, what you have to do, you need to select a material which is having a less corrosion. Some cases you need to use some corrosive resistance products. You can apply some paint or some any external agency on this so that you can improve for some more years. Like that, we have some chemical agents also to control the corrosion, but in some cases we can't do that. That's why initially only, in the initial stages only, you need to select a proper material which is having a less corrosive. Next comes the density. Density is nothing but it can be calculated how much amount of molecules are being inserted into the body. Though we have the same volume, but how the molecules are inserted, density, closely packed or loosely packed. So that describes the density. So this can be calculated by grams per cubic centimeter or pounds per inch, depending upon the units, whether you can follow, whichever the units you follow, you can use those units and you can calculate the amount of density per cubic centimeter or kg per meter cube, like that. So what is happening here? The density of the alloy will determine how much amount of component of a certain size will weigh. So depending upon the density, the weight can be calculated. Okay, I'll show some example to you. You can see here. So these are having same volumes. But if you observe clearly, high density is exactly to the ground and lower density is above. Why means you can see all the molecules. The molecules, what are the molecules are there? They are packed away from each other. They are not close to each other. Though it is having the same volume. But in this case, high density, all the molecules are together, packed closely together. So since they are closely together, what is happening? The weight is increasing. Though the volume is same, there is a difference between the weights. How these weights are being differentiated? Depending upon how the molecules and how the elements are being packed with each other. So in this case, in the low density, the molecules are very, very away from each other. That's why it is low weight. But in this case, you have a high density. The molecules are closely packed together. That's why you have a weight, a good weight when you compare with this, though we are having the same volume. That's why what we need to have here, we have to select a material which is having a lower density or higher density. Depending upon your application, you need to select. So as we discussed in the previous classes, the turbine blades of wind turbine, they need to have a less weight and higher density. Less weight and higher density. So in such a way that you have to select a material which is having a less weight and higher density, so that it will turn the turbine blade at the top elevation of above 50 meters or 100 meters also, because of the high wind speeds are generated. So you need to select a material which is having a less weight and higher density. So that is how you need to know the importance of density in selecting to their required application. Next, coming to the other property, you have the ductility or malleability. So what is ductility? Ductility is the ability of the material to deform plastically. So when you apply pressure on the material, if you apply pressure on the material, what is happening? It is deforming plastically. That means it is being stretched. It is being stretched without fracturing. That is very, very important. Okay, ductility, what is happening when you apply pressure on the body is being stretched but not fracturing. Without fracturing, it is forming into different shape, new shape. So that is called as ductility. Okay. So now, when you stretch a solid wire, suppose if you consider a solid wire, if you stretch the wire, what is happening? It is forming into a thin metal wire. Okay, so that is one example of ductility, but there what is happening, it is not breaking, it is not fracturing. So that you need to know. So ductility is often measured using a tensile test. You can measure the ductility with the help of a tensile test. That means how much percentage of elongation or how much percentage of cross-sectional area. Suppose this is an example we are considering. This is a solid rod. Now when this solid rod is applied a tensile force or a compressive force, so this is called compressive force and this is called a tensile force. Okay. Now when this rod is being applied force, what is happening? So from the top and bottom, if you apply the forces, so you are getting a small wire. So this is being reducing, the first part is being reduced to like this. So what is happening? Initially you have a length of capital L and this is the cross-sectional area capital A. Now after applying the force on the body, what is happening? There is an increase in length, some L plus delta L. There is change in length, there is an increase in length. And what is happening? Whatever the area is there, it is being reducing. So A minus delta A. So what is happening in the ductility? Initially whatever the area we are having, that is being reduced. That's why you are calculating the percentage of reduction in cross-sectional area. So reduction, you can see this point, reduction in the cross-sectional area. Why means? Because you are applying the force, the area is being reduced. So you are calculating the percentage of reduction. Similarly, what is happening? The other thing, there is an increase in length. So you have to calculate the percentage of increase in length in the material. So this is the L plus delta L. There is an increase in length. So with this, you can calculate what is the ductility of the material. So though you are applying force on the body, the material is being stretched without fracturing. So that property is called as a ductility. Next, coming to malleability. Malleability is nothing but the physical property which describes the metal's ability to be formed without breaking. So this is also similar to the ductility. Here also malleability is having the same property. Though you are applying pressure on the material, it forms into thin layers without breaking. So this pressure can be a compressive or tensile. Any force you can apply in order to form into thin sheets without breaking. So now these two are the examples of the ductility as well as malleability. If you see the first example, so here you're trying to bend the materials in different shapes. You're trying to bending this material into different shapes, but there is no observation of cracks here. There is no formation of fracture here anywhere. Though the material is being bent, there is no fracture. Similarly, if you see the malleability, you're trying to form into thin layers. Okay, thin layers, but there is no breakage or any fracture at this point. So both malleability or ductility are the abilities to deform their shape into new shape without fracture. So this is an example of ductility and malleability. So in some applications, the material has to deform but not fracture. So in such type of applications, you need to select the materials which are having a good malleability and ductility property. Next comes the elasticity and stiffness. So elasticity or stiffness. So elasticity describes that a material's ability to regain its shape even after when you remove the force. So best example is a rubber band. So when you apply a force on the rubber band, it will stretch. Again, if you release, what is happening? It is coming back to its original shape. It is regaining its original shape. So that property is called elastic property. Okay. So what is happening here? The elasticity describes the material tendency to regain to its original shape even after removing the force on the body. Okay. So like that, that is the elastic property. So this can be calculated by the help of Young's modulus. You can compare the Young's modulus by the relation between the stress and strain curve, and you can identify what is the elasticity of material. So different material will have its own elasticity property or stiffness property. So again, depending upon your application, you need to select a material which is having a good elastic property. Though you are removing the force, it has to regain its original shape. Then that type of property is called as a elastic property. Now coming to stiffness, what is stiffness means? Now, if you see this example, so these two examples, now you're stretching this. This is my first stage. Now if you apply force on this, what is happening? It is being stretched. There is an increase in length. Now again, after removing this force, what is happening? It is coming back to original shape. So 2 is converting to again 1. So it is regaining its original shape. So that is an example of elasticity. Now coming to the stiffness, what is happening here? Stiffness is nothing but, you take an example of glass. So this is a good example of stiffness. This is having a high modulus of elasticity. Okay, glass is having high modulus of elasticity, where rubber would have low stiffness. So these two, if you compare, then you can easily differentiate between the stiffness of the material property. So glass and rubber, if you compare, glass is having higher stiffness value. When you compare with the rubber, it is having very, very low. Okay, so that is the example of the elasticity as well as the stiffness. Fracture toughness. Fracture is nothing but when you collide, sudden collision between the materials. So what is happening? Sudden collision, there is some formation of crack on the material. Okay, so in many industrial applications, in the manufacturing industries, continuous there is a friction between the materials. Because of the friction between the materials, that means there is a sudden collision or continuous friction between the materials, there is a chance of forming a fracture on the material. If there is a formation of a fracture, what happens? The material will get failure after some time. So this you need to avoid. Okay, so the impact, whatever the impact resistance which is measured, okay, without withstand of a shock. By shock means sudden collision. So that effect, that impact of effect is called as a fracture toughness. Though you are getting impacted or collision between the materials, the material, if it is withstanding without forming of fracture, that material will have a good lifetime. Okay, so this is one example of the fracture toughness. So wherever the sudden collisions are occurring for a short period of time, then the formation of fracture occurs. So this, if you avoid, then the efficiency will improve. Next comes the hardness. Next property is the hardness. So hardness is defined as the material ability to resist from permanent indentation or from plastic deformation. That means though you apply high amount of pressure on the body has to resist. If the body is resisting, then the body is said to be a hard material. Though you apply high amount of pressure, the material has to withstand. So then that property is called as a hardness. Then you can define the hardness without deforming the material. So typically whatever the harder materials are there, these are better to wear resistance or deformation. They won't deform all of a sudden. So they can resist to wear as well as they can resist from deformation though you are applying high amount of pressure. So this is the hardness of the material, and this hardness can be measured using different techniques like you have Brinell hardness or Rockwell hardness. So these are some of the measuring devices which are available to find out the hardness of the given material. So if you find that hardness test by using those Brinell hardness or Rockwell hardness, you can easily tell that yes, this material is having a good hardness value. If the material is failing, that means if it is getting deformed or it is not resistant to wear, then you can tell that this body is having very, very less hardness value. So this is not suitable for your application. So like this, if you see this example, so many materials will have its own hardness values. So if you see from talc, the hardness value is being increasing from bottom. So it is having very less value, about 1 scale, and gypsum is having 2, like that. Fluorite is having 4, quartz is having 4. So diamond, you can see, is in high scale. So this is having a high hardness value. That's why diamonds are used as a cutting tools, since it is having a high scale of hardness value. So this is mostly using a cutting tool values. And similarly, the others, any material will have its own hardness value. Similarly, if you see the example here, fingernail is ranging about 2.5. This is a copper coin. Knife, which is made up of glass. Steel nail, which is having 6.5. And drill bits, which is having 8.5. So whatever the material which is having higher value, these are used for hard working process. So drill bit, why we are using drill bit? So if you want to make a hole, you have to use this drill bit. So if you want to make a hole, means that whatever the bit you are using, tool bit, it has to be very hard. Then how to select that hard material? If you know the hardness value of that material. So you need to find out what is the hardness, then you can use to your required application. Next comes the plasticity. So what is plasticity here? Plasticity is nothing but the converse of elasticity, exactly opposite to elasticity. So what is elasticity there? Elasticity is nothing but once you remove the force, it is regaining its original shape. That is elasticity. So now plasticity is exactly opposite. So when you apply pressure on that, it will deform. Okay, that is called plasticity. So best example is this clay. So whatever the clay you are seeing here, okay, it will deform to the required shape. Whatever the shape you have, it will deform into that shape. It will transform into its elastic behavior. So after some time, it will reach to the yield point. So plasticity is exactly the converse of elasticity, and this describes the tendency of the certain solid material which holds into new shape when subjected to forming forces. What is happening? It is forming into new shape. But in the elasticity, it is again regaining to its original shape. But plasticity is what is happening? When you apply force on that plastic material, it is deforming into a new shape, different shape, not like that elasticity. So that is the main difference between the plasticity and elasticity. So first comes the elasticity, that means it will regain its original shape. Next comes the plasticity, that means it is deforming. So after deforming, what is the end point? Next, after deformation, it will break. So these are the 3 stages you need to know for any material. First is the elasticity property, that is when you apply a force and after removing the force, it is regaining to its original shape. That is the elastic limit. Okay, so that is the elastic limit. If you see in this figure, this like this. After some time, this is up to elasticity. Now plasticity comes, that is deforming. When you apply the force, it is getting deformed. That's why it is falling down like this. So this is called the plasticity. After plasticity, what happens? The material get deformed and it will turn to fracture. That means it will break whatever the material, so completely it will fall. So this is the fracture point. So like this, any material will have its own elasticity property, plasticity property, and fracture point. So you need to know all these things when you apply the material to your application. Next comes the fatigue strength. So fatigue can lead to the fracture under pressure or fluctuating stress. So that is the other point what we are discussing, fracture point. So after that elasticity, plasticity comes the fatigue, that is the fracture point. So it is the end point to the material. So continuously, if you apply pressure on the material, what is happening? At some time it breaks. Is it not? At some time it breaks. So that breaking point is called the fracture. So under high pressure, under repeated pressures, the material will get fluctuated. So internally it will have high amount of stress and the material will get failed. Okay, so this is called as a fatigue strength of the material. So once you know the fatigue strength, then you can decide the lifetime or life cycle of the material which you are selecting to your required application. So fatigue limit refers to the maximum stress the metal can withstand. So this is the maximum value where the metal can withstand. After this value, it will break. So that's why you can tell exactly that this is the limit. So for anything, you have some expiry date. Suppose if you buy a mobile phone, so it will warranty up to 1 year or 2 years. How you are telling that warranty? If you know the end point of that. Similarly, what are the material you are selecting? This material can withstand up to 1 year or 2 years. How can you tell if you know this fatigue value? So this is the fatigue limit is nothing but the maximum value up to which the metal can withstand. Okay, so this is how you can decide the lifetime or expiry of any material. Next, shear. What is shear means? When you apply a force, okay, when two bodies are being collided to each other like this, okay, there is a contact between the materials, there you find some friction. So if you completely apply pressure on these two bodies, there is some shear force. That means there is deformation like this. Okay, there is deformation of the body. You are applying some shear force on the body, so there is some disturbance in the structure, internal structure of the metal against the forces. Different forces are applying, whether it is a compressive or tensile force, what are the forces you are applying. Because of these forces, there is some change in the shape of the material, deformation of the material. So this you can identify by knowing the shear strength value. Tensile, again, when you apply a tensile force on the body. So what is the tensile force? So this is the body. Tensile. This is tensile. That means you are pulling the body. You are pulling the body, applying forces on the two directions, opposite directions. If you are applying in this direction, this is called a compressive force. This is the compressive, but this is the tensile. What is the maximum limit? Maximum limit where the metal can withstand without fracture, without deformation. Okay, that is called the tensile strength. So all these properties you need to know to define, to describe the material properties or material characteristics. Okay. Next comes the yield point. So yield point is also the end point of the material, where after that there is no material useful. It is the end point. It is a fracture point. Toughness. So again, toughness is also used to find out, though you are applying high amount of pressure or continuous pressure, what is happening? It has to resist those pressures. So with this, you can define the toughness of any material. So though you are applying high amount of pressure, temperatures, or high amount of pressure, the material has to withstand without deforming. So this is that you can describe by the toughness value. And the toughness value can be calculated using the Charpy test, which is similar to that Rockwell test, what we are seeing in the hardness. Similarly, here also toughness test can be calculated using this Charpy test. Wear resistance. When there is a continuous friction between the materials, there is a formation of wear. Okay, so this formation of wear can be controlled using some lubrications to prevent the material damage. So this you need to find out. So why we are going to discuss all these things? What is the need of studying all the properties, whether it is a physical or mechanical properties? Means once you know the properties, you can easily select the appropriate material to your application. So what is happening here? Considering what are the information we have studied till now about the mechanical as well as the physical properties, we can promote an optimized metal selection for a given application. So directly, without any knowledge, you can't decide the material for any given application. Once you know the properties, exact physical or mechanical properties, then only you can give the appropriate or optimized material to your application. Now, since the technology is being improved, new research are coming out, we are getting a new improved materials, smart materials. How we are selecting all those materials means by knowing the properties only. by knowing the properties of all the materials, we are trying to identify, we are bringing out the optimized sustainable material, okay, to the required application. So for all these things, you need to study whatever the properties just now we have discussed. If you know all those properties, one can finalize the material to your required application. Now, since why there is a lot of confusion in selection of materials means we have n number of options. We have many types of materials. In the previous session, we have discussed about metals, ceramics, polymers, nanocomposites, all these things. So, since there is an availability of many materials, selection of material is becoming very, very hard. So, how can you select a material means you have to know the properties. Once you know the properties, then you can easily filter a good material that is suitable. Now after that, it will be very, very easy for us for the manufacturing process. That's why, because of the multiple availability of materials and the ability to modify the properties also, how we are modifying the properties? By adding some alloys, by adding some nanomaterials. We are improving we are trying to enhance the mechanical properties. So like that, we have n number of choices to improve. So suppose if we select some X material, so this is having a good hardness value, good ductility value, and high corrosion resistance value, but it is having a very, very less thermal conductivity. So in order to improve the thermal conductivity, what we are trying to do, we are using the same material and we are trying to add some alloying elements or some nanocomposites to this X element, and we are trying to improve or trying to enhance the thermal conductivity value. So like that, we can modify the properties of the materials also. But for all these things, we have to know the basics. First, if you know the basics of the material properties, then only we can rearrange or enhance or modify the properties of the materials. And ultimately, what is the main target we need to have? We need to improve the quality, we need to improve the efficiency, and as well as we have to balance the cost also. This is very, very important in any manufacturing industry. So this is how the material property as well as the mechanical properties of the materials are useful. And if you go through these books, Introduction to Physical Metallurgy by Sidney Havner. So this is McGraw-Hill edition. And again, if you go to the category Material Science and Engineering, so this is one of the book where we can find out all the properties of the materials. And William and Kastler, Material Science and Engineering. This is the Willy publication, 9th edition. So from all these books, you can know what are the physical and mechanical properties of the materials. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.